Uh, Welcome you all to week one quantum computing MOOC online course. This week is defined to be as introductory session of quantum computing course. Session outcomes are: what is quantum computing, what is quantum computer, overview of quantum computing and computers, significance, applications, quantum market providers. What is quantum computing? We all know it is not an classical computing. So quantum computing is a rapidly emerging technology that harness the laws of quantum mechanics to solve problems which is too complex for classical computer to solve. Example, which is computers which is present in market are D-Wave and IBM systems. So many simulators are also present in cloud market, which is by AWS, IBM Qiskit. So much of simulators also present. So quantum computer is a type of computer that uses the quantum mechanics so that it can perform certain kinds of computation more efficiently than a regular computer can. It can perform calculations based on probability of an object's state before it is measured instead of just ones and zeros, which means they have the potential to process exponentially more data compared to our classical computers. Always classical computers will have zeros and ones as output. But whenever it comes to quantum computing, the bit which we are going to deal in quantum computers is none other than qubits. So it is expected to deal with more problems. So instead of counting the definite problem, this computer calculates the possible solutions for that problem regardless of the type. That possibility has a certain amplitude for it to be the right solution. For this to work, computing system should be in superposition state. So qubit is nothing but the quantum bit. As the figure which is present in slide shows the depiction of classical bits which is revealing 0 and 1. Qubit is like a simple bit where half side of the bit will be represented as 1 and half side of the bit will be represented as 0. So it is not going to show one single output in terms of either 0 or 1. So it is going to be in rotational movement. So it is called as superposition states, which is nothing but a basic feature of quantum world, which is called as superposition. A bit can hold either 1 or 0 at one time. Qubit can hold both 1 and 0 at the same time. So theoretically, a single bit can take part in millions of processes at a single time, thus making quantum computer super fast. So this is a maze which has only one or two correct way out. This is an example problem. Millions of other ways which result in a dead end. Now imagine yourself at the center of this maze. You have to find a way out there to reach the destination or end point. So first case, you do not know the way out. So you will start exploring each and every one by one and path, and after millions of tries and years of time you will able to find out the correct way out. Modern computer work this way. Second, now again imagine you have millions of clones along with you. You and your clones will start exploring all the ways together at once. And because all the clones are exploring all the possible ways together, one of the clone will find the correct way out in the first go itself. Thus, you have your solution or way out in the first try. You will get your solution very fast in the first go. Isn't it? Those clones of yours which are present and finding all the ways at once are actually your superposition states. You were present at many places at once. This is called qubit. So now we can have a simple pause of half a minute. Could you able to recollect what is a quantum computing, quantum computers and qubit? Yes, quantum computer is none other than the classical computer. which is going to deal with ones and zeros. Here, quantum computing is going to deal with qubits. Computers means either we can depend upon real computer or we can depend upon a simulators. Qubit is nothing but a bit which is going to hold either 1 or 0. It will reflect the answer in terms of different perspective for different target viewers. I think learners, you all have the idea of what is quantum computing, quantum computers and qubit. Working principles of quantum computing. It refers to computation that uses the principles of quantum physics. Quantum physics deals with the smallest physical units that exist within the human realm. The common principles applied in the quantum system are superpositions, entanglement, quantum interference. The computing is done by a quantum computer or quantum simulator. A conventional bit works with zeros and ones, which is a definite number. However, this quantum method works with qubits instead. Instead of dealing with one definite problem at a time, it computes numerous probability at once. Division in the quantum system are a specific area to house the bits. The approach to transfer the signals to the qubits. A classical computing machine to send instructions towards the system. Is quantum computing real? Many people do not believe that this computing approach is real, or at least they think the concept is not doable at the moment. Various big companies have still working to develop a computer that operates using quantum principles. However, they still run into some substantial problems. Although creating a sophisticated quantum computer is not possible at the moment, experts believe that it will be the norm in the future. The system can help human civilization to solve complex modern problems that conventional computers can't solve right now. Thus, it is understandable that many people are willing to invest in its development. So, how will this quantum computing era will change the world? People can undergo goods much at lower cost because R&D process occurs in the virtual labs. Amount of time to create urgent innovations is cut short. Before manufacturing the items, the developers can detect their possible failures and work on the solutions. Manufacturing process become more sustainable and environment it will be friendly. So quantum computer also capable of delivering best security algorithms, which is going to be useful for the defense field, banking sectors, and altogether confidential data secured applications. Types of quantum computing are analog, quantum annealer, and universal. Analog is a medium which tires the computing systems that is going to apply quantum principles. It can work on several problems at once. So it will deal with 50 to 100 qubits. Quantum annealer is again a machine which is more restrictive and works comparably to conventional machines. So this works one task at a time. It is easy but advantage over conventional. Universal, one of the three quantum computers, Universal might be the most powerful and versatile. It speeds up the data computing process. However, it takes a lot of resources to build this computer as it expected to accommodate around 1 lakh qubits. This will make the computer unworkable in conventional settings. So we can rely on simulators to touch the analog, quantum annealer and universal computing hardwares. Application, it can be applied in optimization problem, cryptographical problem, machine learning task, and data search techniques. Advantages are quantum computing by its usage can crunch a large amount of data. It speeds up data processing time. It is more money efficient in long run. So the larger companies have tried to come up with quantum computer product that can be used by the large populations, including IBM, Microsoft, Google Quail, Airbus, Chai, and Arclab. So this is the console window of a quantum simulator which IBM provides for us. So this console reveals my quantum lab where I have worked with the primitive programs with the help of the Python programming language. So this dashboard comprises of my name, recent notifications, quantum composer and quantum lab launch packs, and circuit execution, which comprise of runtime programs. Whenever we are in need of executing any sort of applications inside quantum labs, we have to pick one sort of console window, which is termed as an IDE, which is relied on a programming language, which will produce solution for us. This console window, I have picked the quantum lab dashboard where I have holded with a file in terms of Python code. The necessary imported files are present as Qiskit libraries. So an application can be customized according to our need. So problems of this quantum computing are these qubits are still difficult to translate into arbitrary values. Readable qubit for public keys, that is a problem, because every reader is going to identify different answer at their time of read. So because it is holding superposition state, this problem will arise. Creating a scalable physical system that can support the quantum numbers are really cumbersome. Developing quantum gates that operate faster than the decoherence time. Creating spare parts that can handle the jobs is also going to be a problem. So this is all about session 1 in week 1. Thank you all.